Today I'm going to teach you about potential energy a bit. I know you're all interested in my clothes. I can see the impending clouds. I'm prepared for the rainy weather, lightning, thunder, anything, but nothing will stop me from learning physics. Potential energy, people, is what we're doing today. It is the energy stored in an object. It has the ability to do work. I'm sure your physics teachers have taught you a little bit about it, but mathematically speaking, potential energy is the mass times Earth's gravitational constant g times the height of the object above the Earth's surface. mg is the weight of the object and is the force due to gravity on Earth. The height is merely the position of the object above the Earth's surface, as shown here. Oh yes, for future reference, in case you have a bogus physics professor sometimes in the future, PE is also known as U sub g, because it's the gravitational potential energy. Let us do a problem sample now, children. The mass of the object in question is 50 kilograms. Gravitational constant on Earth is 9.8 meters per second squared, which is the acceleration due to gravity on Earth. This never changes, ever. The height of the object above the Earth's surface is 20 meters. U sub g, potential energy, is mgh. Means that it is 50 kilograms times 9.8 meters per second squared times 20 meters is U sub g. This is the substitution stage. And thus, U sub g is 9,800, but we don't know what. We need to figure out our units. Now we will learn about the units in order to solve this practice problem. You there! Stop talking! So, we know that U sub g is mgh. So we'll take the units from each component and see what we get. So the mass is kilograms. G is meters per second squared. The height is meters. But wait, the first two variables combine to form kilograms times meters per second squared, which is also a newton, which is also the unit for force. And then it becomes a newton times a meter, which is a newton meter, which is known as a joule, which is the unit for energy. And thus, U sub g is 9,800 joules. Okay, children, in your final stage, we shall see if you have truly mastered potential energy. This is our second practice problem. Again, we have our components of mgh. The mass is 50 kilograms. Gravitational constant, again, is 9.8 meters per second squared, as the gravitational constant is constant on Earth's surface. Height is 0 meters. Thus, we plug it into mgh. 50 kilograms times 9.8 meters per second squared times 0 meters is the new U sub g. But wait, if the height is 0, that means that the object is on the Earth's surface. It's on the ground, basically. So there's no potential to do work. There's no more energy stored in the object. So there's 0 joules of potential energy in the object. Class dismissed.
Hey you! Patient 105, get out of here! You need your medicine!
Welcome to this physics demonstration where I will be showing you the direct relationship between the height and the potential energy. In this example, we'll use a teddy bear on a swing. At this point, the reference point, h, is equal to 0, which means that this is the lowest potential energy because of U equals mgh, and when h is 0, there is no potential energy. As the swing increases, the height increases, which also makes the potential energy increase. When we get to this point, the potential energy is at the highest point because the h is at the highest point. And then as it decreases, h increases and also the potential energy increases until it goes back to the reference point of 0, where potential energy is 0 again. You'll keep doing this, increasing the h and increasing potential energy until the swing finally comes to a stop.